And ultimately, remember, if you generated entanglement, you'd basically be falsifying general relativity for the first time.
Could you tell us a bit about what it is that isn't making sense at the moment?
It's a very good question, because there's a great deal of debate even as to what it is that doesn't work. There are fundamental principles that people think don't sit well together between the two theories. There are mathematical issues and difficulties that we cannot resolve in the same way that we do it in the rest of physics. And then finally, what we are missing is experiments where quantum matters as well as gravity. We have absolutely no experimental evidence which way to go. Hawking, rather than resolving this mystery, I think he even deepened it. But in fact, that was one of these directions where suddenly there is a nice prediction. It says, look, a black hole, according to quantum mechanics, ought to radiate. This is an interesting twist in the whole story. Look, there may be problems with quantizing gravity, but hey, it doesn't matter, because you will never be able to even probe this kind of regime. I think that's what surprised me, actually, with some of these ideas that I worked on, that in fact this is not quite right. I think you could do better than this.
Yeah.
How big can an object be and still be in various quantum superpositions? So ultimately, having a large quantum computer is equivalent to being able to control these quantum superpositions. The immediate question now for gravity: does each of these superpositions contribute to gravity independently? If they are entangled, ultimately, you could rule out a host of theories. So at the moment, I think the technology that would possibly be the most suitable one is nanodiamonds. Our technologies are reaching this level where we could put large enough systems in a state where gravity is significant enough to be really detectable. So that's what's changed.
Hello, welcome back to the Quantum Foundations podcast.